Hello, and welcome to our Signal Media webinar series. I'm George Seifers with Signal Magazine. This presentation is sponsored by Spectro Cloud with participation from Clarity. And today we will discuss using Kubernetes to provide application workloads at the tactical edge. Our guests are Kyle Goodwin, Spectro Cloud's Public Sector Vice President, Tommy Shearer, Principal Solutions Architect at Spectro Cloud, William Crum, a Spectro Cloud software engineer, and Paul Puckett, Chief Technology Officer with Clarity. Today's event will be in the form of a roundtable discussion, and viewers are welcome to submit questions using the Ask a Question box on the webinar console. And with that, I think we can get started. Gentlemen, thank you so much for taking the time for this discussion. We were talking before, and you guys were saying that you felt like the term tactical edge gets tossed around a lot with no real meaning. So for the purposes of this discussion, how do you guys define the term tactical edge?
Thanks, George, and thanks everybody for joining today. So first of all, we have to define edge. Much like cloud computing, it can mean different things to different people and honestly defined in many different ways. From a most simplistic sense, edge computing is about capturing, processing, and analyzing data where it's actually created. So we think of the edge as an extension of the cloud, like a hub and spoke model where the cloud and the data center is the hub and everything outside of that, outside of those spokes, is the edge. Now, if we want to make it tactical, the Defense Technical Information Center actually defines tactical edge in two ways, one from a user perspective and one from a technology perspective. Users being the war fighters actually executing mission at the tip of the spear or that first tactical mile. And from a technology perspective, the tactical edge is where those users operate in environments that are constrained, whether that's by limited comms, connectivity, and limited storage availability. So one of those users we actually have here on the call today from Spectro Cloud, one of our sustainment engineers, in Will Crum. So we're going to have Will Crum talk a little bit about what he experienced at the tactical edge. So Will?
Hey, thanks, Kyle. So yeah, I was in these edge environments. I had my server and I had my rifle. The edge is the forward-leaning area that still requires the same services and capabilities that we often require at the enterprise. We utilize these bare metal hardware in these disconnected environments that are often in like tents, a small shack, or in my environment was a small little remote island, and I had to still support the capability of the commander and the warfighter to make those decision-making necessary needs. So yeah, communication is essential, and not only do we support those capabilities at the edge, but we collect data that's necessary for the commander.
Yeah, I think it's important to add into here, when we talk about the tactical edge, I worked with the J6 team supporting JADC2 and trying to articulate this. And one of the key components that we came up with was the necessity for availability and acknowledgement of latency. So you think there's a lot of real-time necessities that exist oftentimes in those contested environments at the tactical edge, but there's also a necessity for your data when and where you need it. And so oftentimes when we talk about those constrained environments historically, we're typically talking about DDoS, where there's some type of degraded capability when it comes to connectivity or access to information anywhere outside your immediate area. And the typical result of that, to William's point, is oftentimes people are taking everything that they think they might need and they're carrying it around with them. And so there's a lot of challenges in the tactical edge space, but oftentimes it's an environmental constraint, whether that is just kind of the means of the place that you're in or something created by your adversary. So you've got limited resources and capabilities, but you have a necessity to be able to operate and maneuver. And so oftentimes those tactical spaces are absolutely critical when it comes to now how we get access to information, especially in a world where we are growing in our ability to connect with one another, to share information with one another, and more importantly, in the context of the Department of Defense, is no one fights alone. This is a joint and coalition thing, and so the necessity for connectivity and information sharing is absolutely paramount. And that dichotomy of contested spaces and the necessity to share information is where we see this challenge today in tactical edge computing.
Okay, great. Thank you for that. What requirements drive the need for Kubernetes at the tactical edge?
So I'll start off quickly and say that, it's critical to every mission that the ability to get information and intelligence to the warfighters or those small teams conducting the operations in those remote or often austere or hostile environments is important. They have to be able to make the decisions at the point of data collection. And in order to do that, you have to really harness the combination of both edge computing solutions as well as cloud, marry those together. And when doing so, the workloads have to be containerized and becomes Kubernetes and the management of. So those workloads have to be containerized. They have to be distributed across multiple clouds, multiple as a service models, edge servers, edge devices, and so on. And so how do you connect all of those things, much like the hub and spoke model we started talking about in the beginning? And that's really where Kubernetes comes in.
If you look a lot of the current architectures that are in place for many places, you're seeing the necessity more and more to have condensed workloads and the ability to be able to conduct a little bit more with less. And so you see some of the kind of architectural design things being a bit more modular, independent services that work together in order to conduct a mission, the necessity for availability and uptime, the availability for resources to essentially heal themselves. We've got a very fragile environment, so the most that we can start to configure into our software so that the environments actually can kind of fix themselves, if you will, when things go wrong. But then also the ability for deployable capabilities to be able to be deployed into multiple different environments kind of at a point of need and at just immediate notice. And so with those design patterns, we start to see these modular container-based architectures really start to thrive. And to Kyle's point, the underlying infrastructure and platform capability obviously drives the need for container orchestration at a scale and kind of a complexity that really we've never seen before.
I think Paul really nailed it, is that flexibility of infrastructure, that ability to deploy software on something that has roughly the same amount of power as a cell phone, all the way up to the very large power edges that Will was using, and that ability to scale. So if you have more compute available, you can run more process more sensor data at the edge, and more or less treat the infrastructure as an elastic resource, much like we do the cloud.
Okay, and what are some trends that you are seeing in the marketplace?
I'll say from a clarity perspective, I mean, we run a number of container-based platforms for the Department of Defense. There's a few different trends. I think from a platform operator's perspective, we're seeing the necessity to be able to support more and more deployments of platform capabilities running production in a multitude of different types of environments. Like when we talk about the tactical edge, based on the different services, that takes a few different forms, right? We could be talking about actual air platforms. We could be talking about maneuver on the ground. We could be talking about even backpack deployments of soldiers in the field. And so there's kind of a multitude of different type of endpoint environments that have to be supported. We're also seeing kind of more unique and I'd say complex types of workloads, especially more back-end complexity when it comes to kind of like headless services, orchestrating and manipulating data and the movement of that data, especially with the growing sensors that we have in the world that's collecting information for us that we're trying to make sense of in real time. And so we see a complexity in multitude of endpoints, complexity in the architectures, the workloads themselves, but we're also seeing a trend of a lack of really abundant skilled resources, essentially a necessity for very smart people to be able to manage technology at scale, but also have an element of simplicity. Quite frankly, you can't have a master technician deployed with every single group in the field. And so trying to navigate kind of the growing complexity of the architectures and emerging technology just simply means just limited skill sets and people. And so leaning on technology to simplify that is really some of the trends we're seeing. And we also see, quite frankly, people in the product space trying to fill those gaps as quickly as they can.
I think Paul really nailed that, and to simplify it, so Gartner, I read a report actually the other day that mentioned, I believe it was 2 years ago, 10% of workloads were really focused at the edge. The prediction is by 2025, 75% of these workloads are going to be at the edge, and the complexities will only continue to grow with that scale, and the need for those highly skilled resources, or a more simplistic approach to managing those resources is what's important, and those are the trends that we're noticing, and what Spectro Cloud is set out to do here.
Okay, how would you guys describe some of the current approaches, and why do you feel they're not working?
I'll let you guys in the field take those.
Yeah, I think a lot of the current approaches are to lift and shift and move directly to the cloud. Paul alluded to this earlier, is that there's disadvantaged links, and even when running properly, a tactical link doesn't have the bandwidth that has the capability of the sensors that we're deploying. So whether it's high resolution cameras, whether it's passive sonar, you have an inability to transit that much data reliably to a cloud. Whether it be one of the big three public clouds, or even private cloud from the data center. So these sensors are evolving much quicker than our tactical links. So that the traditional deploying your application in the data center or cloud isn't going to give you the insights you need in that contested territory.
I'm seeing another trend of it's just not working too terribly well. There's kind of two different ways to look at it. Kind of to the bit of the point of the lift and shift, I'm seeing kind of a shoehorn into a container-based model that's not actually looking at the architecture and the services. And so, while everyone starts somewhere, the necessity for architectures to be understood for how they work kind of end to end, like that system of systems type of view, is actually understanding that and visualizing that, and then designing your infrastructure to support that. I'm seeing a lack of people kind of do that hard work, which is leading to kind of a deployment of capabilities and technologies, but it's not necessarily meeting the need. But then also from an actual enablement of infrastructure, I see a lot of DIY and kind of custom code capabilities out there to try and manage the complexity, or even just growing more and more and more and more and more, platform teams to try and handle it. Simply because they don't understand the opportunities that exist out there to essentially, handle the undifferentiated heavy lifting, if you will, to a degree, and to be able to provide more and more value when it comes to actually running the mission capabilities that typically, reside within these environments. And so kind of what is that right balance of build versus buy, I think is always, kind of challenging teams. And the necessity for more common and kind of open standard kind of patterns when it comes to how this is going to be supported. I see a lot of people trying to work and trying to, like I said before, fill those gaps, because the DIY thing just simply, it doesn't scale to the degree that we need, to the point that was just made. Like sensors are everywhere. We are collecting data at massive amounts, and we need the ability to process that. And when it comes to the need at the tactical edge, the ability to long haul all of that data back home to some hyperscale to then make inferences from it, we just simply either don't have the time, or we don't have the resources to bring all of it back. And so our ability to process at the edge the most critical components in that real-time way necessitates that we're leveraging technology to handle that scale challenge for us, and not trying to just attack it with people.
Okay,
George,
super. And
oh,
I'm sorry, Kyle, did you?
Yeah, no, one more thing. So what we see a lot in the market from a challenges perspective is, to Paul's point, build versus buy. When the organizations make the decision, okay, now we're going to buy, we want the innovation and we want all of those things from build, but we don't have the resources to do it. We shift towards buy, and traditionally what they've gotten over the past, we'll call it, 5+ years, is whether it's a hyperscaler or other organization that is helping them build, right? It's shoehorning them or pigeonholing them into one specific OS or one specific cloud. And we all know that the hybrid approach is what we need to take for a multitude of reasons. And so really the challenges that we're trying to solve here are how do we give access to innovation without limiting and pigeonholing someone into one specific architecture. And that's really what we're trying to solve for and ultimately make a simplistic deployment.
Okay, great. And also when we were talking earlier, you guys were just describing some really interesting use cases. What can you tell the audience about those?
Right. So we've seen, kind of a multitude of, AI ML algorithms deployed on the edge. I've had experience with deploying Kubernetes on submarines. So taking that large amount of sensor data, so passive sonar, and actually leveraging the ability to train those models during a cruise. So 5-6 months out in the water, and that ability to make that algorithm better, to get better signatures. These were, high-powered boxes with NVIDIA GPUs, and that ability to come back with better data throughout a deployment was very valuable to the Navy.
So from a K3S perspective, which you'll see here, and for those of you who don't know, that's a lightweight distribution of Kubernetes, specifically ran at the edge and the tactical edge. So with K3S, it's actually running in the nose cone of an Air Force U-2 aircraft, and within that aircraft, right, it actually enabled running K3S actually enabled the aircraft to update and upgrade its systems while in flight, traditionally having to be grounded and maybe out of commission for days, weeks, potentially months. To upgrade that aircraft now can be done in minutes, potentially hours in flight. The problem statement is, let's say this aircraft is in a contested environment and without the resources at that in that environment to actually upgrade and fix. At the end of the day, the plane then has to be grounded and resolved, the issues be resolved. And so I guess the point is with the complexities of Kubernetes and not having the smart hands, if you will, on site to solve it, the need is really there for an actual what we would call a tactical edge management solution or a local UI management solution to help break fix any issues on the ground from a warfighter, let's say fresh out of basic training, or a pilot that maybe knows how to operate the aircraft but not how to solve complex Kubernetes challenges.
Yeah, there's a few examples coming out of the Army that I'm really excited about. So the Army runs mission command capabilities that enables command and control for the Army. Most importantly, the ability to kind of see and sense and then maneuver. And historically, that architecture has been just a kind of an edge deployment of a very fixed, very large, and very cumbersome to support stack of capabilities. Hopefully, for most cases, virtualized. What we're starting to see is leaning into a truly distributed architecture that leverages hyperscale cloud if and when connectivity exists, but also has a distributed architecture when it comes to all of the edge deployments as well. And a refactoring of those mission command capabilities to be a bit more lightweight and modular, leveraging container orchestration for how they're deployed, but also how they're maintained day two. There's a lot of stories that probably many can tell of kind of systems going down and their ability to reimage and reconfigure that, taking them days, if not weeks, just simply because of the challenges in the environment, and the ability for now real-time kind of remediation and instantiation of capabilities at the edge. What that means in translation for the soldier is their ability to stay and maneuver and to be part of the fight rather than trying to just get their systems back up. And when we see tactical edge deployments, typically that is a representation of the maturity from the enterprise because oftentimes these edge environments don't live on their own. There's kind of a greater world that they're connected to. And the more mature teams that we see have a solid foundation in which they develop and test capabilities to then buy down that risk of challenges that they'll see in the field. It doesn't eliminate it, but what it does allow them to do is to really focus on that last tactical mile and address the environmental challenges in some of the the random bespoke environments. And then the ultimate net is when it comes to the ability to maneuver the logistics chain in order to support like historical deployments of very large tactical stacks of capability. You've got to have power, which typically means generators, which also means some type of fuel. And that footprint, just from an EW perspective, way too large, way too easy to find. And we need to be able to essentially hide in plain sight. And so these more modular architectures supported by container-based deployments is helping keep soldiers safe, quite frankly, in the field. So not just a technical operations type of opportunity here, but a real necessity to life, quite frankly, in optimizing of these architectures and leveraging these container-based orchestration deployment models for our edge cases.
And to to Paul's point, is this, when I was a Marine and I was active and I was deployed to Indo-PACOM, I had specific use cases where I had to manage about 16 different domains, and these were across multiple ships, multiple forward operational bases, and all of these were traditional virtual machine management. And ensuring uniformity across all these systems was almost impossible. I had the capability to essentially train Marines to do the same thing over and over, but I couldn't use declarative configuration to essentially deploy the same set of capabilities over and over without having to like have sleepless nights. All I would have to do is click a button and run, but instead I had to stay up a couple days and do the same thing over and over just to meet the commander's capability requirements.
Okay, and with those three use cases, what can you tell us about the life cycle and some of the challenges?
Right. So I think, some of the challenges associated with lifecycle is, how do you deploy new applications? How do you make sure that those applications are going to be consistent and compatible with the newer, versions of the container orchestration? So the container orchestration that is, by far and away one is Kubernetes. And it's a pretty fast moving community. It's slowed down a little bit to 3 major releases a year. But that insurance that, as you push new applications to the platform, you have the ability to patch operating systems, keep those within compliance, that ability to upgrade Kubernetes, which gives you security and also new features, and then make sure that the software that's coming out of these software factories is going to be compatible with that new platform. So that ability to make it very repeatable, have that command and control infrastructure to be able to push those updates from everything from on-prem data center to public cloud to tactical edge is one of the challenges I see.
So one of Kyle's points earlier, when it comes to new versions, new capabilities, whatever it might be, you're handing off that deployable artifact, but you're also handing off logic to tell the environment what to do with that deployable artifact. Here's how it should look. Here's how it should run. Here's what we should see when it comes to utilization and performance. Do these things in these scenarios. Having a local instantiation that understands that logic and can maintain that. To William's point, from like a declarative perspective, to say like, this is how you should always look. Go do that, so I don't have to babysit you and make sure that you look that way. Doing that multitude of different places at scale, again, like we said, with various environmental challenges for each. It's very much doable and possible in real today, but it is still challenging, and still understanding that from an operator's perspective, having the right technological background to understand what's happening within the ecosystem. As we say, kind of the golden 10 minutes when something goes wrong, to be able to remediate that and fix it forever into the future. Just doing that again at a scale from a coalition and joint, like from a JADC2 perspective. It's not just like a single organization within a single service, trying to make their own stuff run. we're now essentially a part of a bigger mesh capability as part of that vision, and that's a complex world to deconflict. And so, it's not impossible, but it does not come without its challenges, and it's an interesting world to navigate. So that.
Okay, anything to add there? All right. What can you tell me about the platform Palette Vertex?
Great. Thanks for the question, George. So I guess the first thing I would go to here is to talk a little bit about Spectro Cloud as a whole and Spectro Cloud for government. So first things first, while others were focusing on the distributions of Kubernetes and even in our space hardening those distributions of Kubernetes, Spectro Cloud has always been focused on the management of. So we've talked a lot today about the benefits of Kubernetes, but the challenges of managing Kubernetes, specifically at the edge, specifically with the human resources and just resources in general that we have from a military perspective at the edge. So when we set out to build Spectro Cloud for government, the very first thing we did is I said, okay, let's hire folks like Will and others and Tommy who have worked in these contested environments, have built these things before, and let's take that. Let's go out to the community and understand really what are those challenges that you guys are facing, and how can we build a platform that would meet those challenges right out of the box, I'd like to say, but as quickly as we can. So really what we did was we set out to build a platform both from a commercial and government standpoint that would scale, simplify, and secure Kubernetes management. But most importantly, how do we do that at the edge? Because you heard my statistic earlier, 2025, 75% of workloads are going to be operating within edge computing. So today, what I'm going to focus on and tell you a little bit about is Palette Vertex for the edge. So if we take kind of the first bullet point, I would say from a simplification standpoint, I've talked a lot about complexity at the edge, right? How do we do this in a low touch, zero touch provisioning manner? And how do we do that with Palette Edge native? So one of the goals was really to solve the challenge of day zero deployments to the environments where individuals probably were not Kubernetes experts. Most of the time, these are warfighters fresh out of basic training. So how do we build a way to quickly deploy single or multi-node clusters with little interaction from the individual responsible, aside from actually physically plugging in the device? So trying to get as close to plug and play as possible. So we introduced the concept that Tommy will show you in a bit called stylus operator, which is really responsible for the core components of a Kubernetes cluster. So think OS, Kubernetes distro, and the container network interface. So that stylus operator is actually a part of a lightweight bootstrap OS. Install it via USB stick or flash drive, pre-boot or PXE boot, if you will. And then we do that with the OEM before the appliance is shipped. That would actually provide you that true zero touch experience. But at the end of the day, the end user is simply providing a power and network to the device. It's preloaded and it calls out to Palette, awaits registration, and turns into a full Kubernetes node. So what I like to say is plug, yellow cord into port A, plug, blue cord into port B, and you have a Kubernetes cluster up and running. So we're really trying to bring the zero touch, low touch experience. So easy, someone like myself could get that plugged in. From a secure standpoint, so what we do is we actually bootstrap the OS and the edge native architecture, leveraging an open source project we have called Kairos. So what Kairos is it provides an immutable K8s and OS image that allows us to ensure that there are no snowflakes when distributed across thousands of nodes. So this also gets into the scalability and simplification, but it gives the ability to have an A and B partition with stability checks at that boot, making a huge difference with software upgrades. And these upgrades are done atomically. It's flashed with a new immutable image, and then checks are run against that partition to ensure corruption has not occurred, and then switches over to a new partition. The point here is really remembering that at the edge, there, again, are not smart hands on site. with access to that device. So those upgrades give operations teams an additional level of comfort for OS versioning upgrades and other things that would brick the device or cause some security issues in the field. So on a second note, from a Vertex perspective, we really want to talk about FIPS compliance. So what we've set out to do here with Vertex is comprehensively ensure FIPS compliance covering the entire application layer. So application binaries, artifacts, and the configuration. So the full stack, the management plane, including the OS, Kubernetes, CSI, CNI, and other databases that come into and interact with Pallet Vertex. And then within the platform, we actually will show you if something that you're deploying to or your deployed clusters are also following the FIPS encryption guidelines. And so we've enabled actually TLS by default for internal and external communications and having FIPS status visually indicated in the entire user interface. So instead of just encrypting the binaries, instead of just encrypting the distributions of Kubernetes, we've actually taken the entire platform end to end and FIPS encrypted and had that validated both by NIST Labs as well as through a third-party testing organization. And then finally, and I think one of the more important pieces here is really all about scalability. It's great if we can do this in one-offs, but how do we do this to thousands and thousands of devices globally? So with Pallet in general, you have a decentralized architecture that's based on a principle that management should be centralized and the enforcement and control should be distributed and conducted locally at the clusters. So I talked a little bit about local UI management. So from an edge perspective, the decentralization of policy enforcement is critical. So there's much less traffic between those low power devices and over those potentially low bandwidth networks. Ultimately, right, leading towards a more resilient edge solution. Enforcing the desired model is done within the cluster with those cluster profiles with zero dependency on continuous connection to a central point of management. So the architecture that we've built from a decentralization standpoint truly allows us to scale to thousands of clusters without any degradation in performance whatsoever and securing that simply at scale. So I think that would be my biggest answer on what is Pallet Vertex, and there's lots of other things we could talk about here, whether support for GovCloud and Azure Government and technical support from U.S. citizens, all the things you see here on the slide. But really, I feel that we hit the three most important pieces, and this is all coming from feedback from both individuals in the field working today and individuals that now work with Spectro Cloud directly, providing information on the challenges that they saw when in uniform. So.
Okay, super. Did anybody else want to jump in there, or should I move on?
Well, I just, from Clarity's point of view, we're really excited here in kind of a few different ways. The whole entire point of this entire platform movement is to enable developers to be able to create and deploy capabilities for the mission. That's the end part, is how we accomplish the mission at speed and at scale. But oftentimes what we see are choke points along the way, simply because you need those environments to, one, have complete parity, two, meet all of the kind of the policies, governance, the gotchas of anyone that's tried to field an authorized system within the federal government. But you also need that capability to move at the speed that developers want to move at. And so oftentimes, what we find in a world with necessity for multi-cluster orchestration from a global footprint perspective is the necessity to build more and more and more platform teams to meet that demand and scale. And that can be slow, that can be challenging. And ultimately what that results in is a choke point on developers and how they field capabilities. So net, when we see capabilities like Pallet coming out of the box here, addressing, not just those kind of gotchas along the way, like FIPS compliance, pieces like that, but ways to support people on their journey, if it's VMware based, VM based or container based, type of deployment models, that's cool and great. But then on top of that, the ability for the same platform team to be able to handle orchestration management of multi-cluster globally that removes that constraint to have to grow more and more platform teams of people, and essentially unlocks then the opportunity for developers to create and field, war-winning capabilities. So we're just excited because as a deliverer of capabilities, we want to enable developers to be able to move at speed, and kind of then the complexity of how to meet it and get the job done just always grows. It simplifies that world so that again, the technology can just handle that undifferentiated heavy lifting. But net you have happier developers, and you have happier guardians and soldiers and sailors and Marines in the field, and that's what we want, as the outcome. So we're really excited to see the impact here. I think it's just an exceptional gap that's being filled when it comes to a true multi-cluster orchestration and management.
Will, did you have anything you wanted to add?
I just wanted to agree to everything, essentially. The whole containerization move and allowing small unit leadership to move from traditional virtual machines and into a platform that helps the migration of virtual machines into Kubernetes clusters, while also showing all of the important artifacts of what needs to be in architecture is if it's FIPS compliant and if it's reproducible. It's just immensely important, and it'll save my Marines time, and it'll save everyone a lot of time.
Okay, outstanding. Are you providing the same security and capabilities at the edge as you are in your enterprise environments?
We are, and that's one of the key pieces of the edge is they're no longer protected by data centers. There's not necessarily, four walls to protect these devices. So we actually developed this technology in conjunction with Intel. It's leveraging one of their reference architectures called SENA, Secure Edge Native Architecture. So the concept of this is bringing the parts and pieces to have true security all the way down from the silicon that's produced by Intel, all the way up to the application. So leveraging things like trusted compute modules, the ability to take a bill of materials for every device that's within the edge compute platform, and then making sure that it hasn't been tampered with. So after it's been provisioned, if someone wants to stick something in like a USB drive, it won't have that authority to boot. It won't be able to touch the network. It won't be able to unlock its boot drive. And then once it boots up and it's on the network, then you start to look at kind of the further layers of protection. So leveraging things like policy enforcement, so things like Kibana, that you're only going to run containers that have signatures that have been signed, that are known, good, trusted. That ability to authenticate locally. So no longer having to go through a centralized server to authenticate is critical to this architecture. And then that ability to set policy in a centralized area, so the palette vertex UI, and then enforce locally. And then be able to push out updates as policies shift. And then booting an operating system that is truly immutable. You build that operating system with Kairos and Stylus offline, and then you just push it to the disk via a copy process, and you're not messing with that deployment in place. When you need to bring a new version of Kubernetes or new applications or new containers, you just bring a new image. So you're no longer worried about these snowflakes within the field, that ability to drift in configuration. So all your devices are going to look and feel the same throughout the deployment cycle.
Okay. Are you supporting ways for your legacy systems to migrate into microservice architecture?
We do. So, there's that challenge of not all applications have the ability to be containerized. They might have some legacy infrastructure, legacy code. So we feel that one of the key foundational components to modernizing these systems within the government and the DoD is to allow the use of newer platforms, so containers and Kubernetes, but then also be able to manage those virtual machines right alongside. So there's an open source project that enables the ability to take virtual machines off traditional hypervisor platforms, convert them to an open format, and then run them on the same platform. So you get that economies of scale, you get that ease of management. So you're managing these very much like the new way via manifest files. You can make them highly available, so you can get those tools like live migration for virtual machines. And then as you build this new infrastructure that are leveraging a lot of the key components of zero trust, things like multi-factor authentication, secure TLS, that ability to encrypt all the network traffic, and then also have a private network to where your new applications and your old applications communicate. You can build that border of zero trust and then bring that legacy virtual machine into that trusted platform. So we call this technology VMO. We have the ability to deploy this on a multitude of devices. So you could very well run these virtual machines alongside applications anywhere from public cloud to on-prem, and even moving into the edge.
Okay, great. We're getting some super questions from the audience, so I want to make sure we get to them. How does the adoption of Kubernetes contribute to the hybrid multi-cloud goals with DoD agencies?
So I think what we're seeing with the hybrid deployments is we're still seeing a good footprint of hardware on-prem. In some cases, cloud may have higher access to bandwidth. That ability to deploy some of those applications in public cloud, especially in lower classifications, impact levels 4 or 5. But you may still need an on-prem footprint for the really complicated stuff, deploying an impact level 6+. And that ability to develop on the low side. So we've seen with the inability for people to go to work, that ability to develop and collaborate on the low side, develop those applications, and have a similar infrastructure be able to push from low to high is critical. So developing within public cloud where it's very easy to collaborate, and then push that to a private data center, and then take a subset of those applications and deploy them on tactical edge is a key driver to the adoption of hybrid cloud for Kubernetes.
I think it's one of the most common approaches to enabling a true hybrid cloud model, with the ability to abstract away some of the nuances of various cloud service providers, in order to provide kind of commonality and parity of functionality and capability of the platform environment to support workloads. And so not every workload in the world has a necessity to function in a hybrid cloud model. Probably one of the best examples here is I don't find many customers saying that they want to have an ERP transactional core that can be deployed in numerous different clouds because of some weird necessity. But when it comes to a lot of tactical use cases, sensor capabilities, data processing services, the necessity for those workloads to be deployable in any environment based on anyone's infrastructure is absolutely a de facto standard and necessity. And so leveraging Kubernetes as an abstraction layer against even your own personally owned hardware or some hardware as a service from a hyperscale capability like Azure Stack or Outpost, or even like a Snowball or an Azure Stack Mini, something in some disconnected faraway land. The ability for that workload to see the environment and function the same across all of them is really becoming an imperative. And so for those workloads and those architectures, leveraging Kubernetes is helping address how we maximize any infrastructure anywhere, which is really the core component of that hybrid cloud vision. But to the greater DoD and the intention for just cloud and hypercloud is historically our ability to move at speed has been constrained by our ability to acquire hardware upfront at an extremely high cost, which either means we're buying way too much than what we actually need, we're not buying enough and we're constrained and fragile in our deployment. And so on-demand compute is really a critical enabler. But if you have on-demand compute from 20 different cloud service providers and they all function a little bit differently, then that means 20 different ways that you've got to tweak your workload just a little bit to make sure that it runs. And we don't have time for that. And so abstracted with Kubernetes accelerates our ability to respond to the mission, regardless of the infrastructure and where it's provided.
Kyle, did you want to jump in there?
No, I think Paul and Tommy both hit it pretty hard. I would say, a shameless plug, if you will, is as we continue to talk about cloud, what we're doing. So it kind of goes back to the question earlier about the capabilities at the edge. Is the security and capabilities the same? The answer is yes. What we've done is taken what we do on-prem and do the same thing both in the cloud and at the edge with the capabilities function, if you will, feature function of Palette Vertex. But kind of vision two, or really on our roadmap, what we're building right now is a Kubernetes as a service. So we're trying to take everything that you get out of the software in bare metal, in edge, and run that as a service. And so we've actually have a service built on AWS GovCloud today that we are about to take through the FedRAMP process to get up to those impact level 4 through 6 environments. So even really taking it a step further, that yes, Kubernetes enables the hybrid cloud function, but we're taking it a step further and saying, all right, we're going to also manage your Kubernetes in the cloud. And then the final point that I would say on this from a hybrid cloud perspective, and one of the things that is really important for our customers and what we're hearing a lot is some of the features that we have built in from a costing perspective. So really being able to showcase, if I run, this workload in my own data center or in AWS, what's that cost going to be? And so from a cloud costing and infrastructure cost, it's going to be more cost effective if I run this application here versus there, and seeing those insights in real time on a dashboard are very beneficial to the customers.
Okay.
Here's a question that I would love for us to hit next. If I could read it, people could dive into it. It's from Leo from 18th Airborne Corps. It says, regarding tactical communications, what advantages does containerization have over systems using virtual machines? Who wants to take a swing?
Yeah, I'll take a stab at that. I think the first piece is size. So if you look at, a very simplistic example, something like a web server, if you were to build that within a virtual machine, by the time you get a Linux operating system on there, by the time you get an Apache stack, you're talking, 2,000 megabytes. Versus, if you look at something like that'll serve a web page, as an example at Nginx, we love to use the hello world example within the Kubernetes world. That pod is something like 40 megabytes. So just the sheer size is significantly smaller. And then kind of the challenges that Will saw within IndioPaycom is building an operating system, loading a web server is fairly complex. And then, the complexity hasn't even started until you've exported that virtual machine and you move it and you have to import it. Where, containerization, you can literally, write, 10 lines of YAML code, which is, fairly human readable, and deploy a web server in, seconds. So, part of it's the size, and then that ability to very quickly iterate is if you need a newer version of a stack, you just change that container version. Specifically talking about the satellite problem is where we're starting to see more and more interest of putting containers on satellite and using that container as that means to update those applications. And that's a very interesting problem to solve. You're talking about a low Earth orbit satellite. You probably know better than I do, but you have about 8 to 13 minutes to get a payload on that satellite. If you miss that payload, you're waiting 24 hours to give it another shot. So how do we deliver that payload in a reliable manner and know that container is going to come up and run and ensure that satellite remains operational is a problem that we're starting to be solved. That's starting to be looked at within the DoD.
Yeah, I want to build on that in just a few different ways, because there's another question that asks about secure wireless, and I think that there's some corollaries here. So Leo, who asked the question, says he's part of SATCOM operations. And so size is an imperative. Oftentimes we don't think about someone pulling down a new base image for a virtual machine for deploying, and Leo would know this, for something like mission command services, because they're entirely too large. We're talking about like gigabytes in size of each image. And so typically that is, a DVD. Someone's burnt something, DVD, and shipped those around, and it's this physical instantiation. When we talk about base image size of like, 2, 3, 4, 5 megabytes, tops of like the base image itself, for like a super lightweight and strict like Alpine image, and then the deployable artifact of like the application on top of that, we now have an opportunity to leverage SATCOM to be able to move those things, even if we're in, some of the most, contested environments, or even, say from like a secure wireless, or, say I've just got like an LTE, like if someone's got a phone using some commercial, I've got the ability to now pull down any new image. And so say someone, is pulling in a new data set and needs some new service for data processing, we would have the ability to pull that image down, super lightweight across really any transport medium, and then we're able to run that image. And so again, the opportunity to move at speed, just an imperative. But that's, again, if we just took the 3 gigabyte thing and forced it into a container image, we'd have a 3 gigabyte container image. There's some work that needs to be done to make sure we're being thoughtful in that architecture.
And I think digging into the secure wireless is pretty interesting as well. If you look at the broader community that Kubernetes and the edge architecture are part of, the Cloud Computing Data Foundation, the CNCF, is you can start to look at other projects, things like Service Mesh. And what Service Mesh allows you to do is build those secure tunnels, leveraging FIPS-enabled ciphers. So even if you're on a wireless link that isn't secure, your traffic is going to be secured. It's going to be within a tunnel back to whatever's delivering that application. So leveraging those tools to build that zero trust border gives you that ability to go across multiple links. We had the opportunity to work with an organization that's building kind of a prototype for a distributed nationwide network. So we're able to actually do application deployment over Iridium satellites. We leveraged we used Starlinks for high bandwidth. We had 3 providers of 5G, and then we were also doing data over VHF. And that flexibility of these edge platforms allow you to encapsulate the packets within tunnels, and then go over basically any network. So leveraging things like overlay networks to use a multitude of different links, and you might have a Starlink that's capable of hundreds of megabytes per second, or you might have VHF where you really only want to send lat long over. But that ability to run various applications and know your data link and prioritize data is going to be something that's going to be very interesting in the future.
Okay, great answers to some great questions. We do have a few audience questions that we weren't able to get to, but we need to move on to a demo of the Palette Vertex platform. So for those of you who didn't get your questions answered, the subject matter experts will try to reach out to you offline and tell you everything you need to know. So over to you guys for the demo.
Here's the welcome screen for Palette Vertex. As you can see, we can see a project overview. We can see how the resources are consuming, different clouds, and then we also see a rough estimate of the daily cost. The next thing we can take a look at is some of our edge devices. So if we go to spin up an edge device, this is booting from an ISO. So it's going to pick up this ISO. It's then going to boot into a very lightweight installer. And then you'll see it begin to copy the immutable Kairos operating system directly to the disk of the edge device. So this is after it's gotten its authority to boot, after it's looked at the trusted compute module, and after it's made sure that everything within the platform is as it was shipped. And then you're not doing any modifications in place. You're not building snowflakes. You're not making any changes to the operating system. If you need to patch the operating system or deploy a new version of Kubernetes, you just deploy a new image, and then you go through this process. This can be flashed directly to embedded flash on the platform. Could be a USB stick. It could be, in this case, a virtual ISO, so a virtual CD DVD. It can even be automated through Pixie environment, so booting over the network. And after it copies all the information to that disk, it's going to reboot. And once it reboots, you're welcomed by a QR code. So this is a very easy to grab QR code. You can scan it with a smartphone, and then it's going to take you to a URL. And this URL is going to give you the edge host ID. You can go ahead and copy that to the clipboard, and then you can come back into Palette and actually claim this edge node. So if we go to clusters and we go to edge hosts, we can add edge host and go ahead and paste that edge ID in. Must not have gotten on my clipboard. We'll go ahead and confirm. We choose the microarchitecture with our 4.0 release. We're now supporting ARM64. So lighter weight, lower power devices. In this case, it is an AMD 64. We can go ahead and confirm. Now that we have an edge host, we can take a look at really one of the keys to making this very repeatable and very deployable is this idea of a cluster profile. So this is an example of a full profile. So it has everything from the operating system. So we're doing edge native, bring your own. So in this case, we're using Ubuntu that is hardened, and then also Stig, and includes FIPS validation. So it actually has an Ubuntu Pro license associated with it. We're leveraging palette optimized K3, so lightweight Kubernetes distribution. And then we're using a FIPS validated CNI, Calico. And then we've brought a Kubernetes dashboard. So we're going to give the users a local UI for managing Kubernetes. So once we have this cluster profile, we can go ahead and create a cluster. So we can go to add new cluster. And this is another kind of A/B thing, is if you have existing clusters, you can import them and then leverage this platform to deploy applications, manage lifecycle management. In this case, we deployed a new edge node that we want to bring in as a new cluster. So we're going to deploy a cluster. We're going to choose what cloud. In this case, we have credentials for AWS. We also have an on-prem data center running VMware. And then in this case, we're going to do edge native. We're going to call this edge node. We're going to choose our full cluster profile we chose earlier called Tactical Edge. And here's where we can actually customize how we want it deployed. To give you an example, if we had software-based load balancers, you could put IP ranges in here. You could put a customized system URL, things like that. And since this is sitting on a network, we're just going to give it a unique IP address for its virtual IP. This could also be done by DHCP. We know that DHCP isn't available on a lot of these tactical networks. So you will have to bring an IP. And then here's something interesting as well. So if you're building kind of a larger scale Kubernetes cluster where you want to isolate the workers from the control plane, you can apply labels and taints. You could also create worker pools with different labels. So if you have applications that need additional memory versus CPU, you can stand up those node pools, and this is your configuration. In this case, we're truly going with a lightweight edge device. So we're going to remove the additional workers, and then we're going to check this box right here to allow for worker capability. That's going to allow for a converged cluster. So we're going to be running etcd, the control plane services, and then also be able to run applications on that same device. And then from the drop-down device, we're going to grab that edge node that we claimed from the URL code. We're going to take a look at some of the settings for our scheduled tasks. So we can run security scans against this device, so Kubebench. We can actually penetrate test the platform, see if it's secured, and then look at Kubernetes best practice. We can also look at scheduled backups. This is going to trigger a backup job and push it off to object storage, so S3-based storage. And this can be done, hourly, monthly. You might want to take a nightly backup. So a lot of options there. And then you can also come in here and we'll give you an interface into building the role-based access control, that governance that you can apply to these devices. We're going to go ahead and go to the next step and validate. Everything looks good. And then we're going to go ahead and push the device configuration. So while that's deploying, we can jump into an existing cluster that is deployed. We can go ahead and look at some of those tasks that you can schedule. So one of those is very unique to the platform. It's a software bill of materials. This is a list of everything that's running on the cluster, all the container images. You also have kind of a multitude of different formats that you can output it in. This is an example of SIFT. And then we also have examples of security scans. We can take a look at this and see that it's completed. You can export these in PDF or CSV. So you can pass these on to compliance officers to show that the cluster hasn't drifted. It's still in conformance with the ATO and the CTF. So that's everything I wanted to show today. Thank you.
Okay, great, gentlemen. Thank you so much for a great presentation. And thanks to Spectro Cloud for sponsoring today's event and to Clarity for your participation. And thank you to our viewers for submitting questions. We certainly appreciate your time. And again, if we weren't able to get to your questions today, our subject matter experts have your contact information, so they'll try to get you those answers. Please note that there are some resources available to you under the Resources tab. And to learn more about Spectro Cloud and Clarity, you can visit their websites. I'd also like to point out that you can continue to link to the archived version of this webinar and see previous Signal webinars on AFCEA's Signal Magazine website. That concludes our Signal Media webinar for today. Again, we thank all of you for being with us. Have a great day, everybody.